Good evening, everyone. This is Mrs. Nichols, and today's lesson is writing mathematical expressions. The first thing I'd like you to do before we get started is take about 2 minutes and write as many words as you can think of that mean to add, subtract, multiply, and divide. Go ahead and pause the video and write those words down. Welcome back. Now what I'd like you to do is take a look at my chart. These are words that I have that represent addition, subtraction, multiplication, and division. Once again, pause the video and make sure you get these words written down in your chart. Now we're going to use these words and we're going to write algebraic expressions. For our first example, we're not going to use any variables, we're just going to use numbers to get us started. So if I'm looking at example 1 and number 1, the first one says 8 fewer than 21. Well, if I go to my chart that we just created and I look and I say, well, what does fewer than mean? Well, fewer than means to subtract. So I know that I'm going to have to eventually subtract. And this says 8 fewer than 21. So if I said you had 8 fewer dollars than your friend Sarah, that would mean, and Sarah had $21, that would mean you would take 21 minus 8, and that would represent 8 fewer than 21. And now we don't want to evaluate these right now, although I'm pretty sure you all could do that. We're going to hold off and do that at a later date. Example 2 says the product of 30 and 9. Well, if you remember, product is a multiplication word. Product of means to multiply, and the product is the answer to a multiplication problem. So we want to highlight our operation word, and I want the product of 30 and 9. So I can write this all kinds of ways. I can write the way we used to and do 30 times 9 with an x. But remember, we're working on variables now, so that x can get a little bit confusing. So we can also write 30 times 9 with our parentheses. Okay. And another way we can do that is 30 with a little dot times 9. Those all represent the product of 30 and 9. The next one is 34 divided by 2. Well, this one's pretty straightforward. It says divided by. So I'm pretty sure that's going to be our division. And it's just 34 divided by 2. So once again, how we've usually seen division with our division sign. And then what we learned about the other day, we can actually write that as a fraction, 34 divided by 2. And the last one we have is 5 increased by 10. Well, let's go to our chart. Say I don't know what increased by is. I'm going to go to my chart and I'm going to find increased by. And there it is. Increased by is in the addition box. So my operation is increased by, because that's what's happening. And it's 5 increased by 12. So I have to add 12 to 5 because I have to increase it by 12. Moving on to example 2. Example 2 is writing algebraic expressions. So algebraic, remember, we have variables, numbers, operations, all of those things in the mix. So I'm looking at number 5 here. It says 14 more than a number. Well, let's highlight our important words. I know more than is important. I know 14 is important. I also know x is important. Okay? It doesn't say 14 is more than 12. It gives us a variable which is unknown. So I know that I have more than, which if we look at our box, more than means to add. And I have to do 14 more than x. So x has to come first, and I have to do 14 more than that. So for example, if I had $10 and you had 14 more dollars than me, you would have $24. Our second example, a number y minus 75. So we have minus, which is our key word, which is our operation word, and I know minus means to subtract. I have y and I have 75. Those are also very important. And minus just means y minus 75. Now what's really important about this is here's a quick question for you. Does 75 minus y mean the same thing as y minus 75? Give that a little bit of thought and be prepared to talk about that tomorrow in class. Number 7, twice a number w. Well, we saw in our box that twice means to multiply. So I only have one additional term that we're talking about here. So twice a number w, which means 2 times w. The other way we can write it that we learned today is just 2w. And then, once again, we could also have our parentheses in, and there it means 2 times w there. Number 8, the quotient of 3 and a number z. Well, quotient, if you recall, is the answer to a division problem. So I know my operation is going to be division. And it's the quotient of 3 and a number z. I could also write that 3 divided by z. That also represents the quotient. Now, another question I want you to think about is z divided by 3 the same thing as 3 divided by z? So think about that, and we will talk about that a little bit more in class tomorrow. Number 9, the difference of a number t and 95. Well, difference, I know, that's the answer to a what kind of problem? Subtraction problem. Good job. Okay, so I know I have the number t and the number 95, or the letter t and the number 95, and I want the difference of t and 95, so t minus 95. That will show me the difference of those two. And then our last example for writing algebraic expressions is 5 less than a number x. Well, my important words here are less than, because that's going to tell me what operation I'm using. And less than, if you recall from our box, means to subtract. So I need to take 5 less than a number x. So let's think about it. If I have $20 and I want to say you have 5 less dollars than me, you would say 20 minus 5. So same here. I don't know how much money I have, but I know that you have 5 less than me, so I have to subtract. Now looking at example 3, a little real-world application for you. It says the length of Interstate 90 from the west coast to the east coast is 153 5/10 miles, more than 2 times the length of Interstate 15 from Southern California to northern Montana. Let M be the length of Interstate 15. Which expression can you use to represent the length of Interstate 90? Well, there is a lot of words there, and I really don't need to worry about all of them. What I'm mainly concerned about is I need to know that 153 miles more than 2 times the length. I also need to know that M is the length of Interstate 15. And so those are really my important information. So I know that M is equal to the length of Interstate 15. What it says that the length of Interstate 90 is 153.5 or in 5/10 miles more than 2 times the length of Interstate 15. Well, I know that I can go 2 times the length, which right here of Interstate 15, so 2 times M, and it has to be 153 5/10 miles more than that. So more than means I have to add 153 5/10. So let's see if we can find this expression in one of our boxes. Oh, it's the first one. 2M plus 153.5. This one is subtracting 153. This one is subtracting twice the amount. And this one here is multiplying the length by 153 and 5/10, which we don't want to do that. So our expression is 2m plus 153 and 5/10. And our last example, looking at example 4, says you plant a cypress tree that is 10 inches tall. Each year its height increases by 15 inches. Make a table that shows the height of the tree for the first 4 years. Well, first off, when I plant the tree, which he's 0, that's my first year that I plant him, he's 0. 0 years have passed. How tall is he going to be? Well, I've just planted him, and it says right here, I plant a cypress tree that is 10 inches tall. So he is going to be 10 inches tall, and he hasn't grown at all. If I look at the next year, so once 1 year has passed, well, he didn't lose the 10 inches that he was in the beginning, plus he grew 15 inches in that 1 year. So then I know he's going to be 10 plus 15 inches, which is 25 inches tall. Now if I look at the second year, now he's been growing for 2 years. He still started at 10, so I need to include him. Plus now I have to include the how much he's grown. He has grown 30 inches. So he is now a total of 40 inches. Now looking at the third year, he stayed with his 10, we have that, plus 15 times 3 because he's grown an additional 15 inches. So now I have 10 plus 45 inches total, which is 55 inches. And then for the fourth year, still the 10, and I have to add 15 times 4 because it's 4 years. So 10 plus 60 is equal to 70 inches. So now we have to write an expression for the height after t years. Well, what if I wanted to know how tall he was going to be in 20 years? Well, I could write an expression that I could then plug 20 in to evaluate. So I know for sure, no matter what, he's going to be 10 inches tall unless I chop him down. But he starts at 10 inches tall. And then I have to add his growth, which is 15 inches for every year, but I don't know how many years, so that's where that t has to come from. So this first t at 10 is the initial, that's how tall he was in the beginning, and then this term represents the growth. Okay, so what is the height after 9 years? Well, now that I have this nice little expression, I can figure out the height after 9 years. Well, I'm going to do 10 plus 15 times 9. And you don't know 15 times 9, and you don't have a calculator, and that's okay. So you can either use your multiplication chart or go back to the long style and just do your simple 15 times 9, which 9 times 5 is 45. 9 times 1 is 9, plus 14 is, or plus 4 is 135. So I know that 10 plus 135, he's grown 135 inches in 9 years. Started at 10 inches, so he is 145 inches tall after 9 years. Now what I need you to do for this last portion is take a moment to answer the on your own questions, and then be ready to ask questions when you come into class, as we will be going over these. Okay, so go ahead and answer these 8 questions, and then make sure you write down a question for either me or for someone in the class about the lesson. Good luck and have a good night.